Okay, hi students. So to start to wrap up this aurora bit here in the Earth's magnetic field, let me give you some visuals that have to do with none other than bar magnets. So what a bar magnet is something that looks like this. It's in the shape of a bar like that, and it's usually painted. Maybe one side is going to be all red like this. And of course, magnets always have two poles, the North Pole and the South Pole, and that's why they're sort of painted so you know the difference here. And let me just have you take a look here about this magnetic field created because of bar magnets. So this is a video which moves kind of slowly, but they show you how there's the bar magnet in the image there. It shows you how the magnetic field is determined using both a compass, which as you know works via magnetic fields, and those famous iron filings. So it should start any minute. There we go. So you see they're mapping out the magnetic field by moving the compass around. And you see how the needle is changing direction as it moves around the magnet. It's a very well done video there. They're straight over there once again. And it just sort of comes around like this. They're mapping it out. So this needle responds to any magnetic field that it feels in there. There we go. And then what they'll do, I think, next, so they went around and going around again. Okay, now we start sprinkling the magnetic filings in there. And you can see, well, the magnetic filings move in response to a magnetic field. So you see a rather beautiful magnetic field pattern. And that's what the magnetic field would look like due to a bar magnet. So it looks like it's going to repeat itself, but we don't need to watch it again. Oh, they're sort of showing. Let me let it run for a bit more. They're sort of showing the arrows that the magnetic field points in as seen by the compass. So those little red arrows sort of map out what the direction the compass needle was as the compass moved around the magnet. And you can see it definitely changes. And so as you might guess then, this is how the filings are also going to respond when they're sprinkled on. So see, there you go. See how the way the arrows sort of follow the pattern of the filings, which as we discussed, move in response to a magnetic field. So that was quite nice, I think, there. And so this all told then is the pattern you'd expect from a bar magnet. And I just want to point out something in particular here. Look at the way it's coming out of the North Pole and into the South Pole over here. See the way the arrow directions are? See the way they're coming out of the North Pole and into the South Pole? So you make a distinction over here. These are magnetic poles here. And magnetic poles, there's always two of them, and so is north and south. As you can see there, okay, there's the north, there's the south. Those are magnetic poles. Out of the North Pole, into the South Pole. Magnetic poles, okay? So I left myself a black frame here because I'm only going to draw you now, probably for our final time here, the situation with the Earth. Now we call this the North Pole and that the South Pole, but these are geographic poles. These are not magnetic poles, but you can contrast them if you want. So magnetic, that was on the last graph. These are geographic ones. I'm going to draw a little line through this because that's not what we're talking about pole-wise now, right? These were north and south magnetic poles, but now we're talking about north and south geographic poles. And the reason I say geographic is you can say, okay, well, you're navigating or walking around the Earth. You go north. Well, you're going towards the geographic North Pole. Okay. And so the way the Earth behaves, all told, with the sloshing core and the spinning and all those things that I described to you, it behaves as if there's a bar magnet inside the Earth. So you can visualize the Earth as looking basically just like this. But now the question is, where do I put the N and the S? Because we said earlier with the spinning Earth that these magnetic field lines go into the North Pole, and they do. They go in to the geographic North Pole. That's what we said. They go into the North Pole and they come out of the South Pole like this, like this. And of course, I'll connect them in just a second here, but wait a minute. I thought it was the other way around. Well, it's the other way around with magnetic poles. So the way the Earth behaves is like there's a big bar magnet inside, but the bar magnet's magnetic north is down where our geographic south is. See this here? So this is a magnetic south, and this is a geographic north. that's just what we use to navigate. But as far as the magnetic field goes, the magnetic field lines behave this way. So of course they go all around like this and spin all around the way you'd expect, like this, like this. But the Earth's magnetic field behaves very much like there's a huge bar magnet inside of it. And just note the direction. So coming into the North Pole and going out of the South Pole. So all of the spin and the molten core and all that stuff that I told you about, the net result is think of the Earth as having a huge bar magnet right inside of it with a north magnetic pole down by the geographic South Pole and a south magnetic pole up by the geographic North Pole. This is the magnetic field of our Earth.